For the last 70 years, global defense has relied on a single comforting principle of physics. Gravity is predictable. Since the dawn of the Cold War, the ultimate weapon has been the Intercontinental Ballistic Missile. They are terrifyingly fast and capable of ending civilization. However, tactically speaking, they are mathematically simple. An ICBM is essentially a space launch. It blasts high into the exosphere, runs out of fuel, and then simply falls back to Earth. Because it follows a fixed, predictable ballistic arc, a computer can calculate exactly where it will land the moment it launches. And if you know exactly where a weapon is going to be in 20 minutes, you can fire an interceptor missile to meet it there. It is a complex math problem, but it is a solvable one. But what happens when the math breaks? What happens when a weapon travels at 10 times the speed of sound, but instead of falling predictably from space, it surfs along the top of the Earth's atmosphere, changing direction at will? Welcome back. Today we are decoding the most destabilizing technology in modern warfare, the Hypersonic Glide Vehicle. This isn't just a faster missile, it is a completely new category of physics. We are going to explore the impossible engineering required to fly at Mach 10 and the terrifying anomaly of the plasma sheath, a phenomenon that makes the world's most dangerous weapon effectively invisible. Now, before we can understand the invisibility of a hypersonic weapon, we must understand its speed. You see, a traditional cruise missile flies at roughly 600 miles per hour. It uses a standard jet engine, utilizing spinning turbine blades to suck in air, mix it with jet fuel, and ignite it. But spinning blades have a physical speed limit. If you try to push a turbine engine to Mach 5, nearly 4,000 miles per hour, the air enters the engine with so much kinetic violence that it acts like a solid wall of force. The turbine blades would instantly snap, and the engine would tear itself apart. And so, to go hypersonic, engineers had to completely eliminate moving parts. The solution is the Scramjet, a supersonic combustion ramjet. It is essentially a highly engineered hollow tube. It relies entirely on the forward momentum of the missile itself to physically ram air into the engine. The geometric shape of the intake funnels the supersonic air, compressing it until it becomes blistering hot, at which point fuel is injected and ignited. This is widely considered one of the hardest engineering problems in human history. Igniting fuel in an airstream moving at Mach 5 is like trying to light a match in a hurricane, and then keeping that match lit while the hurricane changes direction. The fuel must mix with the supersonic air and burn in less than a millisecond before it is blown out of the back of the engine. And as though that alone is not enough of a challenge, there's also the heat. You see, at Mach 10, over 7,000 miles per hour, the sheer friction of the air rubbing against the nose of the missile generates temperatures exceeding 3,000 degrees Fahrenheit. That is enough to melt standard aviation steel like butter. Hypersonic vehicles must be wrapped in classified carbon-to-carbon composites and advanced ceramics just to survive their own speed. Additionally, this extreme blistering heat creates a byproduct, and it is this byproduct that makes the weapon truly terrifying. So, when a hypersonic glide vehicle breaches Mach 10 in the Earth's atmosphere, the friction isn't just creating thermal heat. It is also creating so much kinetic energy that it literally tears the surrounding air molecules apart. The friction strips the electrons away from the nitrogen and oxygen atoms in the atmosphere, transforming the air around the missile into a superheated ionized gas. This is known as plasma sheath. It wraps the entire weapon in a continuous bubble of literal fire and loose electrons. To a defending military, this plasma bubble is a nightmare. Modern air defense systems rely on radar. They send out radio waves. Those waves bounce off the metallic hull of an incoming missile, and they reflect back to the dish, painting a target on a screen. And here is where the plasma sheath changed the game entirely. You see, plasma is highly electrically conductive. And when a billion-dollar naval radar array shoots a radio wave at a hypersonic missile, the wave hits the plasma sheath and is instantly absorbed, scattered, and scrambled by the chaotic, swirling electrons. The radar wave never makes it back to the dish. To the most advanced radar systems on the planet, a hypersonic missile doesn't look like an incoming threat. It looks like background static. It is naturally fundamentally stealthy, not because of special radar-absorbent paint, but because it hides inside a self-generating cloak of ionized fire. It is basically a cloak of invisibility. But the laws of physics demand a trade-off. A mirror works both ways. If the plasma sheath prevents defensive radar waves from getting in, it also prevents the missile's own sensors from getting out. You cannot broadcast a GPS signal through plasma. You cannot transmit radio telemetry. And you most certainly cannot use optical cameras or infrared sensors when the nose of the weapon is encased in 3,000 degrees of blinding opaque light. So, basically the ultimate checkmate of modern warfare is effectively deaf, dumb, and blind. It is a sniper bullet moving at 2 miles per hour, fired by an archer with a blindfold on. So, how does a blind weapon hit a moving target like an aircraft carrier from 2,000 miles away? So, the first layer of guidance is internal. Because they cannot rely on GPS satellites, hypersonic weapons use highly advanced inertial measurement units, or IMUs. These are complex clusters of microscopic gyroscopes and accelerometers that track the exact physical movement of the missile from the second it launches. The onboard AI knows exactly how fast it is going, and exactly how many degrees it has turned, allowing it to mathematically guess its location on the globe without ever looking outside. But guessing isn't good enough when you are trying to hit the deck of a moving ship. To get a final visual lock, aerospace engineers programmed a terrifying workaround known as the Porpoise Maneuver. Like a dolphin briefly breaching the surface of the ocean to breathe, the Hypersonic Glide Vehicle will intentionally pitch its nose up and skip into the extreme upper edges of the atmosphere. Up there, the air is drastically thinner. The friction drops, the temperature drops, and for a window of perhaps 5 to 10 seconds, the plasma sheath dissipates. In those crucial few seconds, the weapon's onboard radar eyes open. It takes a rapid snapshot of the battlefield below, identifies the target, calculates the final trajectory, and locks it into the computer. Then the missile dives back down into the thicker atmosphere, pulling the cloak of plasma back over its eyes for the final blinding terminal sprint. Only a few seconds peak from up high to determine where this missile has to go. The introduction of the Hypersonic Glide Vehicle has completely shattered the grim math of attrition. A carrier strike group is protected by the Aegis Combat System, a layered impenetrable dome of interceptor missiles, radar nets, and Gatling guns designed to shoot down anything in the sky. Against a traditional subsonic cruise missile, a naval fleet has 15 to 20 minutes of warning. The computers have time to track the threat, assign an interceptor, launch it, and confirm the kill. Even against a supersonic ballistic missile, the predictable arc gives the fleet minutes to calculate a defensive firing solution. But because of a hypersonic vehicle surfs low along the atmosphere and hides inside a radar-absorbing plasma sheath, it does not appear on the ship's defensive screens until it breaks the curvature of the horizon. At that point, it is roughly 20 miles away, and if the weapon is traveling at Mach 10, 20 miles is covered in less than 10 seconds. And 10 seconds is not enough time to load a phalanx gun. It is not enough time for a human operator to confirm the radar track. It is barely enough time for the automated computer brain of the ship to even register that it is under attack before the kinetic impact tears the vessel in half. This is the new reality of the global arms race. Superpowers are no longer fighting over explosive yields or blast radius. They are fighting over milliseconds. Because in the hypersonic era, the side that wins isn't the one with the biggest shield. It is the one that strikes before the enemy even knows the sky is on fire. Thank you all for watching. If you like this video, don't forget to give it thumbs up, subscribe to the channel, and hit that notification bell.